This video and the following vignettes are going to show the operation of the Hollar's electric winding mechanism for time locks. This particular Hollar is version number 2 from about 1896. The purpose of this was to allow the banker to continuously keep the safe closed past the normal maximum of 72 hours in the case of an emergency like a civil disturbance or an invasion, or for whatever other reason that he wanted to keep this closed for an extended period of time. Now, the rest of this will be a little bit more detailed, but this one we're just going to run right through the demonstration. You'll see here this starts at 0, and I'm doing it at 0 just so that you can easily see how many hours are added for each winding sequence. You'll notice that these two movements here are running. This is not a movement. This is just simply contains gears that connect the motor to a gear set, which will then start winding this. So the very first thing that the banker does is he turns the system on. And I'm sorry, I have to jump in front of the camera because of the way everything is positioned. And then you press this button, and the light comes on. I got to press it a little bit longer. And now it'll run on its own until it reaches the first cycle. And you'll see that cycle on this dial is somewhere around 2.5 to 2.5 hours. You'll also notice that these two movements have now stopped, so they've been disabled. That allows the banker to wind this up indefinitely and to avoid these two from running their natural course down to 0 and either one of them putting the time lock off guard. Now, there'll be further explanations about how all this works and why using only one timer mechanism can be safely done. The time lock is taken out of the case at this point so that we can better demonstrate to you how it actually operates. When it's within the case, you really can't see any of the components. Most of those components that we're going to discuss are actually on the reverse side of this time lock, and so that is what we're going to be looking at next. The electric winding system consists of the following main components. The first is the drive motor here. And next is a solenoid here. And that solenoid is attached to this T-bar here, which moves when it is energized. And that T-bar is connected to a clutch on the inside of movement number 1. I call this one movement number 1. Is the movement that actually is effectively driven by the motor. The motor drives this through a gear set, which is shown on the front and also comes out on this side, and then goes through this wheel, and then is driven through this. The clutch is actuated so that this gear set can actually drive this movement. When it is not actuated, the clutch is disengaged and you're able then to operate the movement by winding it from the front. Now, the next main component is what I call the override bar, which is this piece here. And this bar is connected to a cam follower which follows this as it turns. Now this is going to turn counterclockwise because we're looking at it from the back. but from the front, the time lock moves in a clockwise direction. This cam is actually a three-dimensional cam. It has the lobes here, 1, 2, 3, 4, 5, and those lobes, this cam follower will go up this ramp and go up the lobe and then fall off suddenly. And that is when the time lock is being actually driven, and it is being driven counterclockwise. Later, as the movement is actually running, this cam will now start moving clockwise. And this cam follower, once it falls off of the lobe, these lobes are tapered so that when it starts to move backwards, it will actually be shifted, which is what it is right now, onto a circular area here, just a plain circular area. Now, when it is in that position, the cam is allowed to be fully moved to the right. And the reason for this is that each part here and here has a wire, which you can just barely see right here, which is why I have the movement removed so you can see that wire. That wire touches the gears in the movements number 2 and number 3 and disables them. Another component here is this limit switch. This limit switch is controlled by this piece here. When this piece hits this limit switch, it will automatically keep the motor running until it again falls off of this cam, and then the limit switch will stop. The reason for that is that you start the entire sequence by pushing the on button, and then after a couple of seconds, this will take over. You can release the button, and the motor will continue to wind this until it reaches the end of one of these 5 cam lobes. Now, each cam lobe gives you about 2.5 hours of wind time on the lock. This is now going to be the sequence of events that you're going to see now that I have the time lock hooked up to a 4.75 volt DC power supply. When I push this button here, this will be the following sequence of events. The solenoid will be energized. And by doing that, the movement clutch is now engaged so that this is engaged to the drive wheel set. At the same time, the override will be engaged, so it will stop the movement number 2 and 3 from running. At the same time, the motor will be energized. The motor will begin to turn. Through this set of wheels here, this will begin to turn counterclockwise, and will do so until this runs off of the following lobe down here and drops off. When that happens, the sequence of events will stop. And now the sequence begins. We've now added an additional 2.2 hours to the time lock. So now I've installed all of the movements in the time lock. All of them are running. And So now we're going to start the sequence again. And you can see this time lock has now been wound from 0 to about 2.2 hours, maybe 2.5, depending on how you want to read it on the dial. You'll also notice that now these two movements have been disabled. They're no longer working. And they will stay disabled until this time lock moves to 0. Now the vault is really depending upon one time lock. So what do you do if this time lock stops working? Let's say you've wound this up for the full 72 hours, or how many hours you've decided to do this for, and the vault remains closed. The way to address this problem would be to have a kill switch installed next to this one here, which if I decide to make a control panel, that's what I'll do. But for now, for demonstration purposes, basically what you do is, if this has stopped running, if you push this button, it will continue to turn this. Even if this is not running, this will continue to turn through the action of the motor, and therefore the cams will engage with the defeat lever to allow these two to start running and put the safe off guard. Now the way I'm going to do that is this is the on-off switch for the main power supply here. So I will simply turn this on. And then shut it off. And you'll see that these two are now running and will remain running until they put the vault, or the time lock, excuse me, off guard. So if this cam remains stationary, if this movement were broken, this would remain just like this for as long as it takes for either of these two to wind down. The next failure scenario is, well, what happens if we lose power? What happens if this motor stops functioning? Well, this time lock presumably is still working. And so it will then move to 0 and will also take the time lock off guard. Now, what happens if both this and the motor fail? Okay, well, at that point you have a lockout. So this is an issue with a complicated system where you don't have just a simple time lock with 2, 3, or 4 redundant movements. Here you have electrical components and springs and so forth. So indeed, the threat of a possible lockout while remote is more of a danger than in a conventional time lock movement. Presumably the trade-off is for the function of being able to keep that vault door closed in the case of an emergency like civil disturbance, riot, invasion, and so forth. that concludes the demonstration of the Hollar's electric winding mechanism for their model number 2 time lock from about 1896.